This video on financial maths deals with amortisation, and generally amortisation type questions relate to mortgages or similar loans, or investments which are subject to withdrawals at regular intervals. You might wonder how these two different things might actually end up being the same type of question. Well, amortisation is all about competing, increasing and decreasing balances. Taking the example of the mortgage first. As soon as a mortgage is drawn down from a bank, the amount owed starts to increase due to the accrual of interest. But repayments are made at regular intervals, and these decrease the balance. And this continues until eventually the mortgage is cleared. In a similar way, once an investment is made, its value starts to increase, again through accrual of interest. But if money is being regularly withdrawn from the account, then the amount in the account will decrease. Usually the withdrawals exceed the interest that's gained, so eventually the investment ends up being worth zero, or the investment is exhausted. So when dealing with amortisation questions or trying to identify that a question is an amortisation type of question, keep that in mind. Is the balance increasing due to interest, and is it also decreasing due to withdrawals or repayments? We'll need to have our log tables to hand for this section, and on page 31 we have our amortisation formula. In this formula, A stands for the repayment. Now in the log tables it does say the annual repayment amount, but this is flexible really in practice. It may be a monthly repayment amount just as easily. P stands for principal. This is the initial mortgage value or the amount of the initial investment. Again, just like in previous financial maths questions, it'll be really important for us to match our time units. And this formula is a required derivation on our course, and we'll be coming back to look at that again. So here's my first example. I want to calculate the monthly repayments on a mortgage of 400,000 euro paid over 30 years at an annual rate of 4%. So the first thing to notice here is that I want to calculate monthly repayments, but the figures that I'm being given are yearly figures, so 30 years and the annual rate of 4%. So to begin with, I'll have to sort those out. And I'll do that by finding the monthly rate and the number of months over which the mortgage will be repaid. So we've calculated monthly rate quite a number of times already. So at this stage, pause the video and work out the monthly rate in this case. So we know we're working off this formula 1 plus I equals 1 plus r to the power of 12. Just watch out there with your decimal places as you convert the percentage into decimal. So that's 1 plus 0.04 equals 1 plus r to the power of 12. And after a little bit of manipulation, r will be the 12th root of 1.04 minus 1, and just watch out again that that minus 1 is outside of the root for calculation purposes. And again, I'll keep about 5 decimal places there for that monthly rate written as a decimal. So in this case, r equals 0.00327. Next, the number of months. So we're looking at 30 years. So we're talking 360 months. In this case, I want to calculate the monthly repayments. So I want to find A. That means I must have a value for the principal. And of course, that's just the mortgage amount of 400,000. And now I have all my information to fill into the formula. You can pause here and do that yourself now if you like. Don't forget, this is our formula up here from page 31 of the log tables. And then play and see if you got it correct. Okay. I want to find A, so I'm filling into this formula here. Now notice that in the formula, the P is put out in front, but if you like, you can incorporate it as part of your numerator. Both will give you the same answer. So I'm filling in the P. Now next it says I, and I here represents the rate that I'm working with. So I have everything matched now into monthly units. So I'm going to take the I in this formula in this case to represent that monthly rate. And then I have 1 plus I to the power of t, which in this case is 1 plus 0.00327 to the power of 360. And just notice that in this formula that the power is on the outside of the bracket. And then I'll fill in the bottom. So this is how my calculation should look. And then I go to my calculator and I take great care to type it in exactly as I see it. Make sure the powers are exactly as they are in the written version of the question. Make sure to close every bracket that you open. And again, because this is my final answer in the question and I'm dealing with money, I'll round 2 decimal places. So in this case, the monthly repayment is €1,312.28. And with these types of questions on mortgage repayments, keep an eye to see, does the final repayment amount look like a reasonable amount? So generally you'll find, and this isn't a hard and fast rule, but generally you'll find that mortgage repayments will be in the low thousands. Okay, so here's a very similar question now for you to do yourself. Pause the video here while you give it a go, and then play and see if you're correct. And if you get stuck, play enough to give you a nudge along, but then pause again. So my first job again will be to match my units. So first I'll find my monthly rate and I'll substitute my I value into that. And then a bit of manipulation to get R. And in this case, I have a monthly rate of 0.00247. Note that for all these monthly rate values, I'm leaving them in decimal form because I'm going to have to go on and calculate with them. But just watch out that if you're specifically requested to calculate monthly rate in a question, they'll expect you to change it into a percentage. So next, the number of months, and that's 300, that'll be my T value. In this case, the principal is 320,000 because that's the value of the mortgage, and I'm looking for A, the monthly repayment. So here's my formula, again from page 31 in the log tables. And again, just take care of filling it in. So here's what my calculation should look like. Just double check that it matches yours. And again, just take great care when typing it into the calculator. And in this case, the monthly repayment comes to €1,511.49. Okay, so in this example, Marianne wants to take out a mortgage and the maximum she can afford is 1,200. So I'm being given the monthly repayment. That wasn't happening in the last two questions. The annual rate is 2.5%. And we want to find out what is the largest mortgage she can afford, assuming a term of 35 years. So in the previous questions, we knew P and wanted to find A, and this time it's the other way around. I'll start off though in pretty much the same way by matching my units. Again, I've got a monthly repayment, so I want everything else to be monthly as well. So I'll first of all sort out the monthly rate. So I'll have 1 plus I equals 1 plus R to the power of 12. And you can do this yourself. So if you want to pause here and keep going and then play and see if you're right, that's grand. Just notice here that 2.5% is 0.025. So a bit of manipulation then here. And then I'll go to my calculator to find R. So I've got an R value here of 0.00206. Next, we'll find the number of months by doing 35 by 12. So our T value will be 420. And this time I don't know the principal, but I do have the monthly repayment amount that you can afford of 1,200. So now I'll refer to my formula and fill everything in. So this is my amortisation formula then substituted into, but of course it's the P that I want to get and P is stuck right in the middle here. So I'll have to isolate it. When I'm moving everything across from the right-hand side to the left-hand side of the equation, just bear in mind that anything that's on the bottom, on the right-hand side, will end up multiplying in the numerator on the left-hand side, and anything that's in the numerator on the right-hand side should go into the denominator on the left-hand side. And do bear in mind that all of this information down here will be multiplying by the 1,200, so it's worth your while sticking a bracket in around that before you begin. And I'd suggest doing that before you even move it. Okay, so how's that going to look then? So the numerator on the left-hand side now will look like this when I've moved this information up and over and multiplied it. And I'm really emphasising these extra set of brackets here because if they get left out, the answer is going to be completely off. And now everything from the numerator on the right-hand side comes over into the denominator. No need for an extra set of brackets on the bottom here because everything is already in brackets. And of course, all that remains on the right-hand side is that P, the principal, the overall value of the mortgage. So you go to your calculator now and just take, again, great care typing this in. You don't want to have to do it 3 or 4 times. And remember that for every bracket you open, make sure to close a bracket on the far end. And I'll admit, even as I was typing that in myself, my first go gave me math error because I obviously forgot to close a bracket somewhere. Anyway, P eventually ends up coming out as €337,082.24. Now, a lot of the times in these questions, they may ask you to round off to the nearest euro or whatever, but if they don't ask you, then don't. The nearest cent is fine. Okay, so now an example for you, or not an example, now a question for you. Okay, so here's your question. John plans to buy a house and can afford a maximum monthly repayment of 1,150. What is the largest mortgage he can afford if the annual rate is 5% and assuming a 30-year term? So pause the video here, give it a shot. Again, if you get stuck along the way, play a little bit until you've given yourself a bit of a nudge, and then pause again and go to the end or as far as you can. Okay, so first job is to match my units. I am looking at a monthly repayment, but I've got an annual rate and I've got a 30-year term. So I'll start by getting my monthly rate. So I've got 1 plus I equals 1 plus r to the power of 12. So that's going to be 1 plus 0.05 equals 1 plus r to the 12, and then manipulate and then calculate your r. So in this case, r is equal to 0.00407. Next, I'll find the number of months. So I've got a 30-year term, times that by 12, and that 360 will be the t value. And I'm looking for the value of the mortgage, which is P, and I'm being told the monthly repayment, so that's A. So here's my formula from the log tables on page 31. And again, we just substitute in and then carefully calculate. So I've filled all my values into the calculation, and then I'll have to just manipulate a little bit to get P by itself. And again, just remember, it's a good plan to stick in this extra set of brackets before you begin to move anything. So I've moved everything across. Everything that was on the bottom is now on the top. Whatever was on the top is now on the bottom. Type it into the calculator super carefully. So the biggest mortgage that John can afford is €217,081.63. So both of these questions were really obviously amortisation questions because the word mortgage is being used. So that really kind of screams amortisation. So we know to go to page 31 of the log tables for that formula. But this next question isn't quite so obviously amortisation. So we'll have to have a think about it first just to be sure that it is. So in this example, we have Sarah and she's starting college and her parents want to deposit a lump sum at the start of the first academic year from which she can draw a monthly allowance of €300. Her course is 3 years long and they can avail of an AER of 4.5%. How much should they deposit? Since there's no statement to the contrary, we're also going to assume that she's going to get this €300 12 months of the year. So on a really basic level, what's happening? Well, Sarah's parents are depositing some money in the bank and it's going to start accruing interest or earning interest. So the value of their investment is going to increase. But then Sarah's going to come along each month and she's going to take out €300. So the value of the investment is going to decrease. So once I have this up-down thing going on, it's amortisation. Eventually the fund will run dry and they're planning for that to happen at the end of the 3 years. It's kind of the same idea as paying off your mortgage in full at the end of a term. So again, we'll start off by matching units. So first we'll find the monthly rate. You should be doing this in your sleep by now, so pause the video, work it out and see how you get on. And in fact, if you feel confident in completing the whole question, feel free to do so. If you need to nudge along the way, play a bit until you've been kind of pointed in the right direction and then pause again and try and keep going yourself. Okay, so I'm filling in my figures and I'm manipulating my calculation to get R by itself. And my R value is coming out as 0.00367. Now I'll find the number of months. So we're talking about 3 years. So I'm timesing by 12 and that means my T value is going to be 36. I don't know how much they're going to invest initially, but I do know how much they want to give Sarah each month. And that monthly allowance is the equivalent of the repayment amount, as it's called in the amortisation formula in the log tables. So in this case, A equals 300. Okay, so I've got my formula and I've got all my figures and I want to fill them in. And if you've gotten this far, pause the video, do it yourself and see if you get the right answer. Okay, so I'm going to say that 300. Okay, so we've filled it in and now we want to isolate the P. Again, I'm putting brackets around this entire denominator because all of that is multiplying by the 300 once it moves across. So that's the information from the denominator, first of all, brought across and multiplied by 300. And then we have the numerator from the right-hand side brought across and put in the bottom. And this is equal to P, which will be the amount that Sarah's parents need to invest. So off to the calculator, take care with the typing in. Let's see what we get. And the amount for P in this case comes out as €10,099.64. Okay, so one last question so for you. Let's have a read through it together just to clarify why it's an amortisation question, and then you can fire it away. So Saoirse has received a lump sum of 150,000 on her retirement. She wants to invest this at an AER of 3.5%, and this is in order to provide a modest monthly income over the next 25 years. Calculate the value of the monthly amount. So how much is she going to get every month from her investment? So again, Saoirse is putting money into an investment and it's going to start gaining interest as time goes by. So as a result of this, its value is increasing. But she's also going to be making those monthly withdrawals. And this is going to decrease the value of her investment up until the point at 25 years' time in the future where there's nothing left in the account. So again, up, down, that's amortisation. Okay, pause the video here. So give it a go and then play and see if you're correct. Again, if you need a nudge along the way, play a bit and then pause again. The first thing so we'll do again is match our units. And I'd just like to say at this point that in every question that I've done here, we've had to work out our information on a monthly basis. But this isn't always the case in questions. Sometimes you'll be talking about yearly repayments being made on a loan and a yearly rate in a number of years. And if that's the case, it's fine. You're already in years and you don't need to go matching things. But just make sure to read the question carefully before you begin to launch into it. So in this case, Saoirse is going to want a monthly income. So we're looking at the monthly rate, the number of months and so on. So here's our familiar formula. And I have, ooh, do you spot the mistake? I have 0 zeros on the brain. So just to correct myself there, 1 plus 0.035 equals 1 plus r to the power of 12. I'm going to rearrange to get r by itself. So my r value this time is 0.00287. Number of months is next. So 25 by 12 gives us a value of 300 for t in this case. And this time, am I being given A or am I being given P? Well, A will be the monthly amount that she'll be taking from the account. So I don't have that, but I do have P, the principal, the amount that she's initially investing, which is 150,000 in this case. Right, we're nearly there. Okay, so here's my formula and I have all my values. So in they go. So in this case, A is going to be equal to. So here we have our fully substituted in formula. And again, then go to your calculator and just take care typing it in. So at the end of all that, the A value this time is €746.44. So that's how much Saoirse can expect to be able to withdraw on a monthly basis with this setup. So again, with amortisation questions, just bear in mind, if you see the word mortgage, you're pretty confident it's an amortisation question. Otherwise, stop and have a think. Is the value of the investment increasing due to interest and decreasing due to withdrawals? If so, then it's going to be amortisation as well.